Okay, so we left off where we were talking about number systems. We introduced binary number system, octal, hexadecimal, and the decimal number systems. We mentioned the need to convert between number systems. Why? Because human beings and computers, they don't use the same language. So kuti languages now, kuti those two components they need to be a sort of communication. And that communication is conversion. Tripa break redu na Google logic design in software engineering. My software engineers, I'm not sure what you do there. But simple definition and down up logic design pertains to an abstract representation of data flow, inputs, outputs of the system. Describes the sources, destinations, databases, data stores, data flows, whatever that is in software engineering. Keyword representation. So I think you fit in Kupapakan's representation. So now data flow when you're computer engineering, I'm not sure what's that. But how you represent whatever you do there, that is a logic design and switching circuits. So welcome to the course. Back to my whiteboard. We introduced number systems into data conversion. I'll be quick with this one. What is happening? Just a minute. Just a minute. Wait. Screen langu hapa. Okay.
Yeah, lipo but you blink.
Here we go.
Yeah,
Now,
something.
wait. We'll go through my number basis now. We'll be quick with this one. My number basis, basically conversion. We have a number. I'll give you an example. Here, number 17.81125. This is a number in base 10. It means this is a decimal. This is the representation of a number in base 10. 17.8125 base 10. 101 base 2. 101, 101 base 8. This is how you represent my numbers. Base at the base. I'm hoping that is why it's in the base, but I don't think it is. Anyone find that reason? Can I explain this out with our next time? Right. We want to convert that number here into a number binary. So we'll start with the binary, decimal conversion. How to convert from a number which is decimal to a number which is binary. How do you do it? So we'll start with from decimal to binary. All right, decimal to binary. We have 17.8125. 17.8125. How do you convert this number to binary? Process. This is how I do it. There are many ways to do this. Then up Google, you find many other ways. If you have the time, practice on those ways, you find an easier one. Exam. But this is where I do it. You divide successively. You divide successively using the base kwauri kuenda. For example, here toda kuenda binary, which is base 2. So I divide successively 17 on one hand, then we have 0.8125 on one hand. First thing, separate two my numbers here. The decimal part also run the whole number. Divide successively 17. We have 2, 17. 2 into 17, that is 8. Remainder 1. 2 into 8, 4. Remainder 0. 2 into 4, 2. Remainder 0. 2 into 2, 1. Remainder 0. 2 into 1, 0. Remainder 1. After you've done successive divisions, you take from this number going up. It means 17 base 10 is equals to from the bottom going up. So totangana 1, 0, 0, 0, 1 base 2. 17 representation again base 2. This is how you find it. Successive divisions by 2, then the most significant bit, most significant bit, this is called the least significant bit. So this is the MSB, this is the LSB, excuse me. Yeah, simple stuff, very simple stuff. My example is Mangwe. That is for you to do now. You know, I've introduced you to that one. So up at Tango Dilana 17. I know Dilana 17,8125. Now Takuno Dila, how do you deal with the whole part 17,8125? First, you deal with them separately. Then also no button Dilana 17. Now Takuno Dilana 0.8125. Right, 0.8125. How do we deal with 0.8125? Kumiende saku binary, because this is decimal, right? This is This is decimal. We want to change that number into binary. This is decimal, which means it's base 10. So that's a number into base 2. What do? You multiply 0.825 successively by 2. For the other one, we divide it. For this one, we will multiply. I need this page. All right, so Totanga now 0.8125 multiply successfully by 2. What do we get? We get 1.6250. From the result you wanna unobisa 1. Let's say minus 1 here. Unosar wana 0.6250. Decimal ya wasara nayo or multiply na 2 again. You reach a certain point yekuti paunoramboshi multiply unosar wana 1. 0 to 1 minus 1 instead of 0. So to come multiply this one by 2, watch in another 1.25. To visa another 1. Kuno sara 0.25. To come multiply 0.25 by 2 to know 0.5. Iya inaufura 1. Ine ndo representwa nani na 0. Yoenda kunoko iri zairi because inaufura 1, you multiply on 2 again, you able to paya 1. Then 1 ndiye anoita vhali yako yekupedzisira panapa. Kana wasvika pana 1 or vhali iri around 1, for most mamwe decimal numbers haanyatsosvika pana 1 kechi. So you have to note kana yakusvika pana vhali yako ina 1, then notora vhali yo. So what it means, you have 0.825 is equals to let's say 0, at this point unotangira kumusoro ichidai, it's 0,1101. As a whole 17 wedu abuda ari 17 abuda ari 100,012. Ukabatanidza idzi dziri 2 dzinokubudisa idzi 10001,1101 base 2. Mukaisa pama calculator or pa computers, this is 17.8125 base 10 converted to binary. Basically, this is how you do my conversions, a decimal to binary. For my whole numbers, successive divisions. For my decimals, successive multiplications. You can find better ways to do it, but this is the way I learned. This is the way I am teaching. We are done. Now, how do you go from binary back to decimal? For further understanding, recording I advise recording oral. If you don't want to waste your time, recording. If you are live, we are in a notebook, you take my notes. It is simpler that way. I won't be giving my notes for this course. My course and not my notes because I had time to prepare those notes. This one, I won't be giving out my notes. The videos are everything. So if you take my notes, it will be wise. Because my video I wonder 10, 11, 20 go. It will be very difficult to follow up all the videos. So if you take my notes or build up on my notes, research a bit. My number systems, we don't need to research. This is a simple stuff. Practice using my numbers. My numbers, we can do with those. But understanding counters, my numbers, it needs understanding. You need to research which counters, research my registers and stuff. So for now, practice. Simple stuff you will find in the exam. The exam is number conversion. This is the stuff you go to max. This is the stuff you go to max. Now we want to go from binary to decimal. How do you do it? We are going to use the same example at the Shandisa. So Tawana 17.8255 1 excuse me 10001, 1101 base 2. Takuda kuidzosera kunani 17.8125 base 10. How do you do it? How do you do it? The way I do it, I line up my numbers as a rapper. 1 0 0 0 1, 1 1 0 1. Don't map my numbers. I need another pen. Don't map my numbers. Here, 0, 1, 2, 3, 4. After comma, negative 1, negative 2, negative 3, negative 4. Then my numbers are, they will be my powers for base rangu. So base rangu 2. So for number 4, it's 2 to the power of 4. For number 3, it's 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, 2 to the power of 0, 2 to the power of negative 1, 2 to the power of negative 2, 2 to the power of negative 3, 2 to the power of negative 4. After that, you multiply my powers akho awayisayo by my numbers awatenga kuisa my 1 0 0 1 1 1 9. So you multiply this 2 to the power of 4 multiplied by 1, 2 to the power of 3 multiplied by 0, multiplied by. That's the process. It is kwandiri. That's the process I think you find easiest. Kana kune mamwe process, please do help yourself with those other processes. After you are done with this, wako add. You add, so panap pekutanga ish. Tina 2 to the power of 4 multiplied by 1. 2 to the power of 4 is 16. Plus 2 to the power of 3 multiplied by 0, 0. So we have 0 here, 0 here, 0 here. We have 2 to the power of 0 multiplied by 1. 2 to the power of 0 multiplied by 1 is 1. Comma 2 to the power of negative 1. 2 to the power of negative 1 is half. 0.5. 0.5. Answer. 2 to the power of negative 2 each here. 0.25, I think. Plus ish in it as 0. 2 to the power of negative 3 multiplied by 0. 2 to the power of negative 4. I don't know about the answer. Participate. 2 to the power of negative 4. Let me calculate. 2 to the power of 4.
0.0625.
Ichi?
0.0625.
0.0625. Right. We have these two numbers. Now, what's the adder? So we will have, what do we have here? 16 plus 1, that is 17, comma, 0.5. Let's share this. Let's share the screen. Right. Let's remove this. What screen language is this? Yeah. My tools are over. Okay, I cannot share my screen. To calculate, unfortunately. So I'll just calculate Murima. 0.5, Vardo calculator Wangwatuana answer plus 0.25 plus 0.0625. It is equals to 0.188125. It is the same as this one. So this is basically how you convert from binary to decimal and vice versa. For examples, my assignments are well. I think I'm going to let you know this, but this is simple stuff. Trust me, believe me. Abana at all. Right. So basically, for any other conversion, any other conversion, from base number X to decimal, either binary system, octal system, hexa system. How do you convert? Point number 1, successive divisions by base. For whole numbers. For example, let's say this is A, comma, B. Number is A, comma, B. So successive divisions for the A part. Then we have successive multiplications by base for the B part. Then the other way around, ndiyoaukisa mapowers, ndiyoaukisa scribili zvangandiri kuita ziya ziya. If you did understand. Kana usina understand that the video is always there, or YouTube, Google is always there to help you. Trust me, Papa. We move on. We move on. Any comments, any questions so far? So far, so good. We move, my comrades. Right, we have a binary to octal. Binary to octal. Binary example, we have 6538 octal. Hey, pandanyepa octal. Yeah, kudara. Yeah, octal is number 100. Right, your octal number is 653. We want to convert it to binary. How do you convert it? 1. Each octal number converts to 3 binary digits. Chat. Can we please get the videos as soon as we are done the lecture, please? Okay. How do we convert that? 1 point to dot. Each octal number converts to 3 binary digits. Our binary digits, we are now used to them 10, 10, 10. Now, each octal number, the 653, for example, in this example, each 6 I don't represent 3 binary digits. 5 I don't represent 3 binary digits. 3 I don't represent 3 binary digits. If we had another number there, it will be represented by 3 binary digits. How do you represent 6 in binary? You need to know now my numbers are. How do you represent them? Name sorrow. How we did it is either 2, 6. Thank you very much. 6 will only represent as a 1, 0, 1. The easiest way, represent my number. Say, I always do this 4, 2, 1, 8. For 4 numbers, the binary. The guys are 1 pan up, it's 4. The guys are 1 up is 2. The guys are 1 up is 1. The 8 as they say is this is 4 plus 2 plus 1. We have that 4 plus 2 plus 1, 4, 6, 7. Which means this is a 7. Sakana nchida with a 5, dunesa 1, pana 4, dunesa 1, pana 1 pana. So 5 anengari 1, 0, 1. Kana ndikuda with a 10, dunesa 1 pana 8, dunesa 1 pana 2. So we have 1, 0, 1, 0. That is the easiest way you would deal with my binary. So now, Panan?
Para 6.
Yeah.
I saw 101. It's 110.
Thank you very much. Zvikora kuti pana vanhu vari kuparticipate pana. Munanzani comrade?
Chingwe.
Chingwe. When you participate, you get noticed. Mchaona yenyu comrade, vari kukuseka here. But Chingwe, when it comes to nyaya kunegotiate, mchaona kuti you get noticed kuti kuna Chingwe. So this is 110. Comrade, makorrect kamazona. So for 3, it's 0, 1, 1. Right. There we have it. So can also represent the whole number 653. 653 can attack the kuisa ko octal system. So it is equals to 110. 1, 0, 1, 0, 1, 1. In
653 tiri kuisa ku octal rekana ku binary.
Tukisa ku binary. Thank you very much. 653 octal irenda ku binary. That is how we do it. Simple stuff. Representation iyo muchisa uma space up kuti uone the difference inini kuti ndione especially kana ndakumaka ameno computer I'm sure haidi maspace aya but inini
Hello.
ndikumadayo you can also represent it like this 110101011 all fair and fine but inini ndikuda kuiona yakadai because I can easily identify kuti number yabviswa ku-octal issue. Right. That's it for octal to binary. Which means kana ndakuda kubva ku-binary kuenda ku-octal, there is no simple way but yekuenda via decimal first. Kana ndakuda the other way around, actually there is an easier way. Kana ndakuda the other way around, chat on chat also gonna taura kuenda kuchat kuri kunetsa andisanda nyatsobata chinhu chandirikushandisa panapa makomboresi. Wait a minute. Chat iri kutaura kuti hanzi manotes hakuna. Can you also get notes? Manotes hakuna. Thank you very much. Video iripo Craig but manotes hakuna. Right. Here we go again. So apa tabva ku octal tikaenda ku binary. Takuda kubva ku binary kuenda ku octal. Binary takuda kuenda ku octal. Process yacho yangoda kufanana but in vice versa. The first thing you do is to group my numbers in threes. Then unotsvaga kuti decimal equivalent ichi. For example, yatabva naita iyoyo yabuda iri 1 1 0 1 0 1 0 1 1. This is binary. We want to convert this number to octal. What do? You group them in threes. Kustangira this side. So not 1 2 3 1 2 3 1 2 3. Okay. Then what about 0 1 1? This is my equivalent ichi. This is my equivalent here 0 1 1. Tikashandisa 8 4 2 1 0 panapa 1 1. So this is 3. Opposite, this is 3, this is 5, this is 6, base 8. This is how you convert. Very simple stuff. Now we have hexadecimal. Your hexadecimal then no viringe. I viringe as much, but those are my students. They always have problems in hexadecimal. But easy stuff. Hexadecimal, running out of time. Right. Let me just do hexadecimal and we are done for the day. Hexadecimal. All right. How do you go from binary to hexadecimal? Hexadecimal. Right. If you have a number 3A F9, this is a hexadecimal number. Right? We want to go to a binary. How we do it? Each hexadecimal number converts to 4 binary digits. The same way, patapa pa octal or each converted to 3. In this case, converted to 4. So 3 ananaita 0 0 1 1 4. Kuvapa 8 4 2 1. A ndiani ku hexa. Hexadecimal yakamira yakadai 0 1 2 3 4 5 6 9 A B
N10.
D E F. Thank you very much.
10.
A ndi 10. 10 akamira akaita sei apo pa 8421 yedu anenge akamira ari 1 0 1 0. 9 anenge akamira ari 1 0 0 1. F then 11 12 13 14 15. 15 anenge akamira ari 1 1 12 14 15. So this is how you represent number in hexadecimal, and vice versa. Kana wauda kudzoka kuno, it means you group them in 4 first. Vichitangira kuno 1 2 3 4 1 2 3 4 1 2 3 4. Dai, for example, panapa tisina these two. Tati group, tati change this binary number to zvinouya zvakaitwa muexam. Apa muri kumaona ari mafofu akakwanirana ka. Exam inouya mafofu asinokwana. Utovhunzira kuti ndakutovharwa, but no, hausi kuvharwa. You group ma4s ako from this side 4 4 4. Kana asinokwana ari 4 unoedzera ma02 obva ita 4. Then wakutsvaga decimal equivalent or 8421 equivalent yako. This is 3 and etc in base 16. So basically, this is how we do my number conversions. I have 6 minutes. Right. We have last one, octal to hexadecimal. Last one, octal to hexadecimal. Mamwe ese hapa nsina explain hapa is because they are simple and they are necessary to explain hexadecimal. For example, how to go from hexadecimal to decimal. We need the same process at data binary. Divided by 16 successively. Then not from a remainder of most significant byte iri pasi kuchikwira mudenga. Right, this one to convert we have the same ngati nayo 3A9F 16 toda kuendesa ku octal. How do we do this? Convert from base 16 to base 2 first. So conversion yekubva ku hexa to octal inopfuura via binary first. How do we convert it? That convert kuendesa ku binary kudare. Tawana iri 0 0 1 1 1 0 1 0 1 0 0 1 1 1 1 1. Data bono convert my manje. Why bisa pa binary then wozoendesa ku octal. Kana wakuenda kuendesa ku octal, tati the first thing you do, you group it in threes. So nichagroupa ma threes aya 1 2 3 1 2 3 1 2 3 1 2 3 1 2 3, then we have 0 0 anabasa. So tama groupa kudai ish, it becomes, this is what? This is 3 yekutanga ish, this is 8 4 2 1. Or follow different variable. That's not this one. This is 4 5. This is 5. Then we have 0 1 0 0 1 0 2 0 1 1 2. This is 3 1 1 1 1. This is 7. Base
7.
Base 8. And we are done with number conversions. Number conversions are better now. Assignment in a tunutko. It is cheap stuff. It is stuff. The counter exam in a tunutko. Marks up. I repeat, Pamoska counters, Pamoska registers. And it is what it is. We are done here. Questions?
Se kopa ine
Kopa
mati pana 0 hana basa. Kana pana 1 tinaita say.
Right, kana pana 1. We come here. Right. Don't put the hands up apana 0, apana 1. Unoedzera ma 0 first, wait at 3. Then 0 0 1 inenge 1. So short pakuwedzerwa 1. You get it?
Yes, sir, thank you.
Any other questions? Manamba basis tapeza. Zvikora kuti part 1 yedu yapera. Where is our course outline?
Hello, sir.
Question?
Yes, I wanted to have clarification on the very first part, of the lesson.
Yechi.
Where the 1 0 where you were showing the binary, like a binary waveform.
All right.
Some books show
some
books show that without
without
I mean zero inenge iri pa axis chaipo, not below.
Okay, right. It depends on the representation yamushandisa. For example,
Okay.
kana ndine signal, you don't define a representation yako. For example, ndikaita
Okay.
signal iri, I can define it kuti maximum panapa ndochi 1, minimum panapa ichi is 0. I can also define signal iri ndoroda so on. Not maximum yangu do 1, pana 0 panapa ndochi 0. But it all depends the definition. As seasons no fun or confuses. It's nothing. It all depends the definition is signal. You define what say. You will not define a number levels with maximum level do 1, minimum level do 0. In this case, minimum level redo up. I see 0 we do up. But in this 0 minimum. The 1
Okay.
maximum. You get it?
Yeah, I get it.
Any other questions? I think we are done. Dandalo Kutatopeza because outline this one. Almost done number systems. Almost done number systems. Chasarapo number complements. So Kutitifambene next time we meet, research out my number complements sheet. How to represent my negatives, my positives. Number complements, 1s and 2s, less than 1 minute. This video is going to cut anytime, so I probably won't have time to go by. Say to kumbira course outline. Course outline, I think on a snowy on the computer engineering. I'll send you a group menu. And I think that's it. Thank you all. One HNE, specifically Christine Gunu and Theodore. Theophilus or Theodore Chipoi. My presentation is Takama Mirira. Thank you. Good afternoon.